Hey guys, I wanted to show you a little trick I use to troubleshoot furnaces. It's a 24 volt test light, and what that does is it'll tell me at what point in the sequence of operation the furnace stops operating, and you can test it rather quickly and get to the problem, then pull out your multimeter and do some more extensive testing. The first thing that you need to know is what the sequence of operation is. Every piece of equipment has a sequence of operation. This one's a generic one. So what we're going to have on a sequence of operation for a regular furnace is 120 volts of power coming into the furnace and into the integrated furnace control. That 120 volts is going to have to be the right polarity, and it should have an equipment ground, and that's needed so that the flame sense will work. So once you have 120 volts coming into the furnace, the control board is going to send 24 volts out on R, and the thermostat will send 24 volts back to the furnace on W on a call for heat, and then the integrated control board is going to do a safety check. It'll check the limits to see if the limits are open and the rollouts are open, and then it'll start the inducer. The inducer will pull a negative draft on the pressure switch. The pressure switch will close, sending power back to the board, telling it to send power to the igniter and the gas valve, and then you'll get spark or hot surface. You'll get the gas valve opening. You'll get main burner. Flame sense will take place, telling the board that there is indeed flame, and that'll, in order for the gas valve to remain open. And then after the timer goes through its time, whether that's 30 seconds or 1 minute, for the heat exchanger to warm up, the indoor blower will come on, and it'll run until the thermostat's satisfied, which the thermostat will then open, and there'll be no power on W. So then the board will go into shutdown, turn off the burners, and then the timer will come on and run for 90 to 180 or so seconds, typically, to cool down the heat exchanger. So this tester is an OEM Tools 24 volt tester. You can only test 24 volts with it. If you touch 120 volts with it, you're gonna blow the lamp. It does come with an extra lamp. So we're going to look real quick at the sequence of operation here. I'm going to take the tester. Oh, I should tell you that you want to make sure that you leave the sleeve on the tester, and you want to tape it so just the tip is showing. As you can see, just the tip of the tester is showing there. And the reason you do that is because if we put this tester on a terminal or on a 24 volt wire, and then we accidentally touch the gas valve, or the gas line, or touch it to ground, it's going to be a direct short, and we're going to fry something, either the fuse or the board. So you have to be careful. So we're going to turn this on real quick. Once you energize the circuit and you get 24 volts back on W, then the whole limit circuit will be energized. So you'll have 24 volts coming in, going through the switch, coming back out, coming over to the next rollout, going through the switch, coming back out, going to the next rollout, going through the switch, coming back out, and going through the high limit up here, which you'll have power coming in through the high limit and then back out. So if the furnace is energized and we touch here, and we have a light, we have 24 volts going to this side of the switch, and then we touch this terminal and we don't have a light, then we know that this high limit is open. then you can get your tester out. You can do an ohm test on it, or you can check for 24 volts. You can use this tester and go to your fuse and check on both sides of your fuses to see if you have power. You can use it. You can touch R, you can touch W, you can touch Y in cooling, and it's going to light up if there's 24 volts there. You cannot touch 120 volts with the tester. So you have to know the difference between what the 24 volt control wiring is and the high voltage 120 volt wiring is. So make sure you know what you're doing before you go sticking a tester in there. So here we go. This is a sequence of operation. We're gonna get inducer, and then we're gonna get pressure switch. So I'm gonna come right over here, and I'm touching the pressure switch. You can hear the inducer come on, and the light's not on. There we have a light. Next we're gonna have spark. This is a ream furnace, so it has a sparker. And then if this was, most other furnaces have hot surface, so you would see the hot surface glow, and you'd have gas valve. I'm going to go ahead and put my tester on the gas valve terminal. Sometimes it comes on right away, and sometimes it takes a minute. There you go. You see that spark? We have 24 volts on the gas valve. We have main burner. So if while this was running, we come over here, we have 24 volts. Let's say that this switch went out. Let's say that there's a problem. Let's say I had a bad heat exchanger and the flame wasn't drawing directly in, and it made this switch open. I wouldn't have 24 volts on this side, so I know it's a switch, right? I have 24 volts here, but nothing here. See, I have 24 volts here, and I have 24 volts in here, over here. I can't reach it. There's 24 volts there. My main limit up here. See, 24 volts and 24 volts on both sides of it. If one side didn't have it, then I would know that there's something wrong with that switch. Just like right here, I have 24 volts coming into this switch, into this pressure switch, and I have 24 volts coming out. Or I don't know exactly how many volts. I'm using a light, but you can tell if it's real dim, it's not 24 volts. And then you would go and get your voltmeter out and test it from there. I'm going to shut the gas valve off. So now we have a flame sense failure. The flame sense coming back on the orange wire here is going back to the board now. Here's my flame sensor in there. You see that rod, and that's what gets dirty. And you need to clean it. Here you can see one that's not installed. The rod should be firm in the porcelain. It should be clean. Even where your ground screw goes in, it should be clean, and your terminal needs to be clean. And you can clean your flame sensor with real fine steel wool. There's all kinds of debate about that. We won't get into that today, but now you see it's going on retry. My furnace retried, and it's going to retry one more time. We'll go over here to the gas valve, and you can see there's no light, so I don't have any power going to the gas valve at this moment. When it tries again, it'll send 24 volts to the gas. There we go, see? So we have 24 volts, we have main burner. I'm going to shut this off again because I want to cool the heat exchanger down before I turn it off. I hope that's helpful. That gives you an overall picture of the operation of the furnace very quickly, and it helps you to pinpoint what point in the sequence of operation you have a problem. So if you have inducer and nothing on the pressure switch, then either the inducer fan inside here, the impeller, is not pulling negative, or you have a crack in your hose, you have a bad pressure switch. But your test light helps you to get to the heart of the problem a lot faster than pulling out your meter. At least I've found that to be true. I hope that's helpful for you. I hope it saves you some time, and It's just one more tool in the old toolbox to help you do your job better. So thanks for listening. You take care.